Okay, so hi everyone. So today I was going to do something maybe a bit different from usual. It is going to be like another book speed run, but this time this is a book that was offered to me by our good friends at Pact Publishing, and so they were asking for my opinion on this book, which is a book on generative AI with Python and TF2, and harnessing the power of generative models for images, text, and music. And so I haven't covered all that much like sort of generative or GAN-like content uh, in the past on the stream, but there's kind of a couple of stuff that I think are interesting upfront that are important to think about before we dive into the book. So generally in ML, if you look at the traditional supervised learning setting, we're basically trying to find the probability uh, of an example given some some features, right? Or some model weights. So this is like your model, right? And then this is the example, and then this whole thing would output a label. But instead, in generative ML, what we're really gonna do is we're gonna have like upload some examples. Yo, how's it going, Pseudomates? I know it's been a while since I've done a stream, so appreciate your patience. Work has been very busy. But yeah, I mean, so regardless, like what we're gonna do is we're basically gonna be coming up with examples, right? And so X is a very general thing. Like X could be like it could have multiple forms. Let's draw a couple out. So it could be a scalar. It could be a vector, like let's say tabular data. It could be a 2D image. It could be music. It could be like video. It could be a 3D model. So really, anything you can think of can be generated in this way. And so, kind of, I think a lot of these ideas became really mainstream, at least in more applied settings, like with sort of the rise of GANs, right? And what GANs were is it's hard to explain GANs without explaining autoencoders first. So very quickly, let's say you have some sort of input, and then you have your model. Um, like instead of trying to predict another output, you want to try to predict what your input is. So a very common way of doing this is like if we were to zoom in on the model, it would essentially have the structure where the layers get smaller and smaller, and then you would make them bigger again such that the size of the input matches the size of the output, right? So this was sort of the idea behind autoencoders, and they're really useful. They probably work very well and kind of be my default, I guess, for doing anything like this. And GAN sort of add an interesting twist to this. So you have like you have your model, and then you have the generator, which is gonna come up with examples, and then you have a discriminator that takes in an example and then tries to predict like a label of like basically is this real yes or no. And so part of what makes this sort of setting challenging is that you have two networks that you're training in conjunction, and so the ideal discriminator is also depends on what the ideal generator is. And because it's sort of like this like game between these two things, the training can be unstable, especially if either the generator or the discriminator are stuck in a sort of local optimum. Um, and so, like this is sort of more fancy stuff, but you could think of it as, you know, why should we care about something like this, right? And like predicting the being able to regenerate the input in of itself isn't very interesting. And so, what we really often want to do is you want to generate uh, new, interesting things, right? And so I put quotes around interesting because this sort of depends on how you define your problem, right? And so let's say we want to have things that we haven't seen in the input distribution. That could be, something that's something interesting. Could be new. it could be basically generate something with some desired properties. So, like let's say you think of something like I'm saying, a lot. Let's say we're doing something like StyleGAN, for example. So you have an image, right? And then now you want to have you want to feed it a new style, and then you want to feed this to StyleGAN, and now you want an image with new style. Right. So this is like one way, for example, of encoding a new property, or like let's say instead of a style, like this could be text, or it could be just like an actual image. Like you give it another image and you tell it like, well, draw it in this style, and then the style would be extracted by its own network. But this is kind of what I find interesting about this space is that like how can you guide your networks to generate stuff that's interesting for you? Another application would is probably a bit more useful. I mean, this is useful for like automatic content generation, even though I don't know anyone who uses this in a real game yet in ProcGen. But I mean, let's say eventually people will, and maybe people like Sean Presser or Gwern will create good software for people to use. And I think in terms of when I think of who does interesting work with GANs, I think Sean Presser and Gwern are probably the two most prolific people I've seen on Twitter. Um, and yeah, so definitely make sure to follow them if you want to see a bit more how these ideas actually work. But let's take another example where we want to generate proteins. Okay, so I have a whole video on proteins and amino acids and stuff. But at a high level, what they are is you have an alphabet. Let's say so AC. Let's say I don't know, you have this thing looks like this, for example. I can't actually read what this means. So let's say you have this thing, and this is, let's say, a valid protein. But what we want is, for example, a protein that we want like so. This is basically the thing of it is like the image. Sorry, the input, and we want to figure out like what changes do we need to make to this thing such that it becomes like heat resistant. So for example, so we give it like basically extra information. We say it has to be heat resistant and I don't know, penicillin resistant. Okay, it looks like we're designing the next outbreak virus here. I'm gonna have Resident Evil if we do this. Regardless, so we have like we may have we may have inputs in several data formats. Like some could be text, it could be an image, it could be a vector, and so the idea is okay, great. How can you sort of combine all of these things together and then have an output with the properties that you want? So I'm not going to answer how to do this right now. So this was a whole intro. But I thought, like, since I myself am not an expert on GANs, I thought, we could just use this book. The reviews look pretty good on Amazon. So let's just give it a try and see what we think. And yeah, like I said, I mean, even though I'm reviewing this book, I'm just gonna be honest at this point because there's certainly a lot of books, and if it's good, I'll be sure to say it's good. Yeah, yeah, it doesn't really matter. I think TF2 and PyTorch look very similar at this point, if I'm being honest. Um, okay, so let's just take a quick look at the table of contents. Like they talk about discriminative AI, generative models like style transfer, the unique challenges. Okay, for some reason, then we talk about Kubernetes and Docker and Kubeflow. So these all fall under the heading of, I guess, productionizing ML. So I'll just call it ML ops. This looks like an intro. Even though this is all chapter one, that's interesting. Um, yeah, okay, this is neural net summary. Let's see. Chapter three is Boltzmann machines, encodings of images. Okay, this looks a bit specific. I don't know how this chapter fits into their overall narrative. Um, but I guess yeah, like let's just say image, yeah, like image rec part one, image gen. Sorry, this looks like image gen part two, part three. Yeah, I don't know. Like I feel like these should all have been compressed down into one chapter. So maybe this is gonna be kind of lengthy, but we'll see. Yeah, and I guess like now they talk about like NLP, NLP in general, and then generative NLP. I know that's confusing. Okay, music. Okay. Yeah, I mean, this is more what I was looking for. Just like, how do I generate stuff with interesting data sets? Okay, then RL. And then here, I guess, yeah, they talk about proteins and PDEs. Okay, yeah. So this is like a bit more of the crazy applications. All right, sure. What was this book for? If you're new, PL Python programmers, the code is available here. Okay, it's cool. Let's take a quick look at the code. Um, highlight. So it's hands-on generative AI. All right, I mean, I think this could be good. Let's see what's going on. All right, looks like it's downloading a bunch of stuff. Okay, okay, CD hands-on. All right, let's take a look. It's interesting, yeah. Like they're doing it, making it more of a point to explain some op stuff. Let me zoom in a bit. I saw that. Like I was considering going over it. So let's see here. Okay, so there's like a bunch of like shell scripts to set up containers. So like a registry name, a training image path. Okay, what else is there? And Azure CLI, you can log into Azure via the terminal. You can set up a resource group and a cluster. It's all good. I typically do prefer to do most of the stuff within the context of Python because like I don't really know the syntax for Bash well. Yeah, I think like I may just end up looking at the Andrew Ng class as well because I think it's going to be relevant. Here's what he has to say because it's been years since his last class. Like, okay, some thing with like a vagrant file. What's vagrant again? Surprisingly ops heavy, right? Like, okay, so they're using these deep belief networks where they define DBN. It's the library. Oh, from models. Okay, so they do build it from scratch. I mean, you see what I'm saying? Like, it does look very similar nowadays to PyTorch, at least structurally. This is kind of a long ass training loop, though. So you top level associative, okay. And a top pi with nothing, something with the cache here. I don't know what this is about. Or why it's here. Probably just a mistake there. Um okay. Let's see. Rbm layers, Rbm. Oh, these are restricted Boltzmann machines. I see. Okay, I'm just again taking a quick look. So they have the VAEs here. It's encoder Gaussian NLP. I mean, they do have like lots of different architectures, which is interesting. Yeah, like the encode decode. I think TF function makes it easier to compile this just in time and make it faster. Or why not make the rest TF functions? I forget. So Gaussian MLP. Okay. So what does Bernoulli NLP mean exactly? So you have two hidden layers, two dense layers, one with a tan H, one with a sigmoid. That's it, right? There's no. So why the name Bernoulli? What about Gaussian here? I thought it would be related to the way they initialized the variables in the network. Anyway, let's keep going. Conditional GAN. I mean, they are pretty generous with the number of examples. I think that is one. It's all documented. I see. Okay, this is nice. Oh, this is cycle GAN. We talked about this. No, sorry, we talked about style GAN. Okay, setting up params. You have these downsample blocks. Okay, so this looks a lot like UNet here, right? So you have these downsampling blocks and then the upsample. Even UNet reminds me a lot of like autoencoders used for segmentation. I'm assuming this is doing something similar. So then the discriminator has some discriminator blocks. Where's the discriminator block? Defined number input layer, number of filters, and then input layer output. Oh, I see. Okay. Upsampling to the sequential model. So where is the? Oh, that's cool though. This is a cool trick. Get data sets from someone. Upsample block. I just don't know where the discriminator block is coming from, but I guess it's probably maybe here. Yeah, this looks like it. So the upsample block, instance norm, sure. Concatenation of the upsample. Yeah, no, it has the same thing, right? Like it is very similar to UNet here. And then the conf to D, the upsampling. Yeah, I think this looks exactly identical to like a UNet layer. So the downsample is you have a convolution, then they have a leaky relu, and then instance norm. I've seen different kinds of norm. I think the norm I saw with the vanilla UNet paper was just using group norm. It's a general heuristic of like don't make stuff too big or too small. All right, they also have some data utils around getting a batch of generators, batch of images. Okay, so there's definitely, I mean, already we can see a bunch of commonalities in the code, right? Like there's some network, there's some way of computing how good this is on a certain batch of inputs. What is this here? So this is training the, oh, this is the vanilla again. Okay, yeah, maybe let's go through this. So we load some data from MNIST, and here they're only taking the training data. Then we rescale it to -1, 1. So this normalization. That's what this is doing. You have some GAN output labels. So one is they take they take the real. I guess, yeah. Is this the real Y's? NP zeros, batch size 1, and fake Y's NP 0, batch size 1 again. Uh, Okay, how do they use these? I think I'm missing something. So Okay, so you have an index, you take a random index from your training data, um, and then you take a random image from this index. Okay. I mean, I still don't see where they're using real Y though. Let's see, real Y. Okay, so here we're using it. Discriminator train on batch, real images, real Y, and then calculate discriminator loss on fake samples, train on batch, fake images, fake Y. And then the overall discriminator loss is the real and fake. We add them. And then okay, so you take the average. And then what do we do? We add some noise. Okay. And then we add the noise to the, so we add the noise and then model train on batch, noise, real Y. How does this work again? Okay, let's take a look at the train on batch function then. So discriminator uses cross entropy metrics. Okay. Okay, so we're just looking for this function, train on batch. Maybe it's in Ganitals. No, yeah, I mean, I do get the fake and real part. I'm just like, let's see, train. Yeah, I think like one thing I'm not a big fan of here is that a lot of the code feels really redundant. So it indicates that maybe the book could have been, they didn't compute the loss until the first two sets are complete. Yeah, so there's only like they're training on this batch, then they train on this batch, right? So the discriminator is being trained on the real. Oh, I see. So it's being trained on. Okay, so first you train on the real ones, then you train on the fake ones, and then you train on noise. It looks like no, like we're training the use train discriminator to improve the generator. Okay, so the train discriminator to improve the generator. So the noise is completely random. It looks like. Um, and then I really just need to look at this. Where's GAN model defined? So GAN model, GAN model, GAN model. Okay, so it's coming in as an input, but I really just want to look at what the train on batch looks like. Because, so in this batch, we're giving it real Y, and then we're giving it noise and sampled labels. I mean, yeah, maybe. I feel like there's probably another another book just rewriting this all this in Python. But yeah, I mean, I see now that why there's so much code because like a lot of it does repeat quite a bit. Maybe we're being too harsh. Like I think because we haven't even opened the book, right? Okay, these are reference from Nicolas Cage and okay. Let's have fun. Open and collab. Easiest money of my life. All right. This warning is not authored by Google. That is fine. So what's MTCNN? It's a face detector for Keras. I see. I already started. Interesting. Okay, so then it gives you some key points, like basically the XY coordinates for all of the main landmarks in your face, like where your nose was, or your mouth was, etc. This is pretty common actually. Like I've seen this sort of structure before. Um, anyway, yeah, so just downloading a bunch of stuff. Utility function to mark and visualize faces. That's cool. And then instantiate the image detector. Then you load an image. Why is this not working? Assertion failed. Source empty and function color. Did it just not install something? Does the image exist? Oh, I see. Okay, so we needed to manually load the Trump data. I see. Okay. Could a W get it? That'd make my life just a bit is easier. So which chapter was this? This is chapter 8. Chapter 8. Where's the Trump photo? Okay. Can I just W get stuff like this? Or maybe copy image link? Where is it? Copy image address. Let's see if this works. Something happened. So we're gonna copy the path and then we're gonna say image read this. Does this work? Oh yeah, it worked. Okay, cool. So then detect images. Okay, well, like now that I went through this, like, what? Why is this its own notebook? It feels a bit random. Uh, this is also another facial landmark library. I guess they're using it here in Pix to Pix. Like there's like this Obama video live reenactment. We will leverage a live feed to extract facial landmarks. Okay, and then landmarks would then be used to generate reenacted frames of Mr. Barack Obama. Okay. Okay, what about 9? What's going on? Okay, 9 is fast text. What's fast text? So enriching word vectors with subword information. It decomposes each word into a set of n-grams. Um, we will leverage the 20 news group dataset to build a skipgram based word to vec model using Jensen. Alright, that's kind of cool actually. Is this useful though? How does this work? Space tech? Like, how do you. What do I do with this? Okay, so it's like the data is ordered around, like, it looks like there's like this, like inverted, like sort of a V shape. So if I go on I5, I see. So these are all like numbers, it looks like, and then these are what, like words. So it's split it according to digits versus. Okay, so what happens if I just go down like this? News stating applicant would much based also series trading. Yeah, I don't know how to read this. Like, never mind. Uh, yeah, it is cool though. Like, I don't use TensorBoard enough, and no, yeah, I get the how to visualize embedding. I'm just like looking. I'm like, I can't really make a sense of the order of it because stuff that's close doesn't necessarily have any interesting meaning. Like, let's see if I go here. I don't know. Set worth sun long GD corresponding. Okay, never mind. Um, okay, but I guess you can get similar words. So God is believing, believe, ontology. Yeah, it's like whole ontological argument. I don't know if you've heard of it. Basically, um, there is no uh, like there is no being more powerful than God, and if uh, God and if you do find one, that new being is God. Therefore, God exists. I'm using my undergraduate philosophy background right now. But yeah, anyway, I don't know. Like this is cool, but it's not sort of core to the. It's not core to what this is trying to what the book I think is trying to express. So I don't know how useful it is to have this stuff here. It seems like they just added it to add it. Like let's see here, it's okay. Well, there's a sequential with an embedding and LSTM. Like it's cool. Like I like it. I just think the book could have been a bit more focused. Oh, GPT-2. Yeah, so they're gonna install Transformer, get the ABC News. They're gonna read the news. Um, okay, then they're gonna write the. They're gonna open another file and then write stuff on it. Okay, so instead of having it, so he's gonna read it and then he's gonna write it back on a list. Okay. So then we're gonna use the pre-trained tokenizer from Hugging Face. We're gonna load a data set. We have a test data set, a data collator. And video SMI is very useful. Does watching commands work in VS Code? Google Cloud? I'm curious. Let's check. New notebook. NVIDIA SMI watch. I'd be very surprised if this work. Actually, let's see. GPU. Oh yeah, it does work. It just spams my console though. So like, let's say if I say now like 2 plus 2, will it ever get to it, or I'll just keep executing the top one? Yeah, no, this is not great, right? Let's just use this Tesla T4s. This is cool though. I didn't know you could know exactly what GPU it was. Like, god damn it, stop, leave. Okay, what's the Tesla T4? Yeah. I'm used to the V100, A100 thing. Honestly, I'm not really sure what this means. And I've used K80s. Maybe if I put, you got a Titan X, crazy boy. I'm sure it's for deep learning research and not for gaming. Although I was wondering because I have a 180 Ti in my other PC, and so I was wondering if I use it, can I stream games that are more GPU intensive by having one GPU use my streaming setup and another GPU actually render the game? Your advisor seems really generous. I don't remember my advisors buying me GPUs. I still love him, but yeah, no GPUs. Okay, let's get rid of this guy. Let's see what else can we find that's interesting in the code. Okay, so we're gonna use Hugging Face. Okay, so then there's some audio stuff, Audio 101. Apt install Fluid Synth. Oh, so you can convert MIDI to WAV. Okay, so you can listen to it. Yeah, Librosa is a library I've seen a lot of people use for this stuff. Okay, so let's see, C Erlangen. Let's look at it. Right now, you have no excuse not to work, right? He gave you all the resources. So, yeah, I saw that. I think Torch Audio is like definitely picking up the steam. Is this PyTorch? Am I? Oh no, it's still a TensorFlow. Yeah, see, this looks very similar. No, no, yeah, this is Keras. Sorry. So wait, we were using TF2 now. Yeah, I thought this looked familiar. Keras is great, actually. I mean, it was my first, library. I think that I felt very comfortable with. It's like fuck it. Who wants to set inputs and outputs? I just want to set the output. Um. Okay, yeah. So what's the general structure of this? So we have a dense layer, leaky ReLU, bash norm. That's okay. So just generic something that works over images. Um. Okay, great. And then we have the discriminator actually, but this is not images. Like we're actually working over audio, right? Okay, fine. And then the discriminator has an LSTM vibe to it, where we have an LSTM, bidirectional LSTM. You guys just have more bidirectional LSTMs. Dense layer, leaker, LU, dense layer, Xavoid, and Sigma. Okay, sure. It's kind of interesting how they have like very different. Are you going to post this video to YouTube? Maybe, maybe not. We'll see. You can give me the pros and cons of each. Because this is definitely, I think, slower than the other ones. So we'll see. So prepare the sequences. Create directory to map into just integers. Okay. Create MIDI. You tell me what to do. I'll do it. Let's put it this way. Um, yeah, it's again the similar structure, right? Like you train on the real example, train on the fake ones, you add up the losses, and then you train the generator on noise. I think seems to be, and I sort of like this pattern. I want to say something, but I don't know. Oh, I see. Okay, you want to say something? Okay. Um, you know, you can always DM it to me, and I can open it up on my PC, so everyone knows like how horrible of a person you are. But yeah, like this is one thing I like actually in this example. Like at least it makes the sort of this pattern very obvious. Like so basically, you generate a batch of new node sequences. So generator predict the noise, and then you get like you train the discriminator on real, on fake. You get the loss, and then you train the uh, you train the generator on noise. And then, okay, they visualize the progress, and then they generate. Where is generate defined? Generate. Okay, yeah, there we are. So generate takes a bunch of input notes. Okay. See, this is one thing that's horrible about Python. I'm just like, what is input notes? Like, is it a list? Is it a tensor? Like, who knows? I think we'll figure it out soon. Okay, yeah, so it looks like a list. So we have a list of notes, maybe probably in text, it feels like. And then you make them a set. Okay, sure, but let's say you're just playing A. Would that be like you would just collapse it? Then you say into note. Yeah, so you're basically getting sure like number to note. Okay. Now pitch names. Use random noise to generate sequences. And then you predict the noise. And then your prediction of no for nodes is x 242 plus 242. Why is the 242 special here? I'm not sure. Okay, and then you finally create the MIDI. What about this guy here? See attention. Sent on Discord. Okay, I'll open it up later. Um. Okay, well, this again looks a bit similar. Oh, it's scale. Sounds fancy. Ooh, we're doing RL. Let's open up this example actually. Buy bullet gem. Ooh, this looks fancier. Actually, what happens? Like, does Google Collab actually have buy bullet gem? Does this work? I have a feeling this is not gonna work. Buy bullet gem. Let's see. Pip install. Why wouldn't they put this on? They need a requirements.txt or something, right? I feel like maybe some. They do have it, but it's empty. I've found to have an interact a remote Jupyter notebook on a cluster server in VS Code. Yeah, like you're talking about the SSH functionality. It's really nice. Uh, they can put this on PyPy, so not copy that. Okay, I don't want to deal with this right now. But yeah, I feel like this could use a pip install e. Does that require? I mean, the requirements.txt looked empty. Is it in the setup maybe? What's going on here? Ugh, Ben, where's your requirements.txt? True that. Speaking of Souls, I've been debating replaying the Souls games, but I also realized that life is too short for me to be playing 80-hour video games all the time. Although, like, one thing I like about the game is that it feels like I don't know, because I was never really able to read fiction, because I feel like I get sort of my fiction buzz from playing games. Um, and I think like just storytelling in an environment is way more interesting than like spoon feeding me descriptions. Like I think that was one reason why I could never read novels because I just felt like I would get very bored when I read long descriptions. Um, okay, I think we got a pretty good idea for the code base. So without further ado, I am I have ADHD. That is true. Uh, I do think I think everyone has it though. I think it's like people try to ignore too much boring things. I think it's healthy to be ADHD. Is this Nicolas Cage or am I seeing things? I mean, yeah, like I think so far I like this motivation a lot actually. Yeah, so they talk about TensorFlow. It's all good. Okay, so they really go over like so many of the generative architectures. The promise of deep learning. Okay. Oh, that's cool. I hadn't considered GANs for art reconstruction. It's kind of interesting. These are look pretty good actually. I guess especially that Picasso went through various phases. Fake news and chatbots. Okay, sure. Like online, although I would not recommend using an online therapist. Um, it'll basically be a bot asking you, how do you really feel until you rage quit. Yeah, there was this funny story my parents told me about. It's like some some service was doing like an online therapist and people got attached to it and then turns out it was like a bunch of scammers and they told people like, if you don't send us x bitcoin, then we're gonna, release this to the world. A big part of the therapist relationship is that they're probably not gonna do that. Yeah, it is. It's a horrible story, right? It's a bad one. Okay, so they talk about stuff, infrastructure. Have you used the Terraform before? I have not. Yeah, everything else looks familiar. Yeah, maybe I'll just do a quick overview actually. So basically, like little containers where all of your dependencies are there and everything just runs, but you don't have an internet connection and you can't do most of the stuff you can do with a regular VM, like that's Docker. Kubernetes is the orchestration engine, so if you want to sort of elastically scale different microservices, then Kubernetes is the way to go. Although I don't know, I feel like more people are going to move back towards like monoliths because these architectures are getting really complicated. Kubeflow is basically this, but geared more towards ML pipelines. So having pre-processing pipeline, a DAG of models, and then like an output, etc. Let's take a quick look at Terraform. I'm curious. By HashiCorp. Why does that sound familiar? Okay, Terraform init. Okay. Terraform plan. Okay, apply. What's going on? So how is it different from what AWS does with like Terraform versus CloudFormation? Yeah. Is it just like, oh, it's a wrapper on top of a cloud so you can move to whatever cloud you want? Yeah, I see. You see how I'm good at guessing this stuff? It's just it's multi-cloud and then it can be a sort of a layer on top. Oh, holy shit. Okay, that's dark. So I guess what did you learn? Don't build an AI therapist, I guess. Um, just tell yourself how do you really feel in the mirror over and over again. Or get married. I think like those are probably like better alternatives for for sadness. Okay, so then they're talking about like model sizes increasing drastically over time. It's funny, like AlexNet is considered big. Can you just get AlexNet? Yeah, I mean, like it's interesting here. Like VGG, I think was like because I downloaded it recently. It was nothing. It was just like maybe like 500 megs or something, like maybe 800. So BERT is really also nothing. It's just like 1.5 gigs, and then GPT-3 is. Let's see if NVIDIA can keep up with their on-device memory. Okay, so I do like here how they mention how TensorFlow's like graph structure lets you do distributed really easily. What do you think, NVIDIA DS team? What do you mean by DS team? Dataset team, Rapids AI, data science team, Rapids AI. I'm not too familiar with really what they do. I'm familiar to work in Python. Oh, interesting. I wasn't familiar with it actually. So it looks like they just have like stuff on top of like okay, like memory performance data frames, QML. Yeah, I mean, I think I'm a fan. Like anything that makes my life easier, why not? I think it makes tons of sense, right? Because like ultimately people don't want to write their own like shader programs or CUDA programs. It's too hard. So like the more you can, if you know everyone's doing the same things, right? This is like pip install, setting up some like data loader, and then a data frame. Because I think like that's what would be interesting about them having their own data frame, right? It's that like let's say it's really big and it doesn't fit on memory, then I would imagine that it becomes NVIDIA's responsibility to make sure that the data gets loaded quickly and efficiently and the GPU's well utilized. Or if you have a data frame but you're using distributed data parallel, that like you can very quickly send data to the various like GPUs that you're using. I'm not sure if Pandas uses CPU. Actually, that is a question. Does Pandas use GPU acceleration? It doesn't. So they use it with QGF. It looks like yeah, they don't. I think that's the primary reason why like NumPy isn't the deep learning library for everyone. By the way, it's just because they never properly supported. I think GPU acceleration. If I'm not, maybe they do now, but I don't know if this is super necessary. It's like here is VS Code. You have a terminal. I think I've seen this image before. I don't think this is theirs. Um, I mean, let's see, because let's see a Docker. Like one thing I didn't like about Docker is that like why not use more shell-like syntax? So here they say from public ECR. Okay, so get this notebook and then copy and then you change owner and then you copy the requirements txt to the container. And then once it's copied, then you run pip install without caching, and then you remove the requirements. Okay, sure. Like, I mean, this is sort of a detail, probably whatever. It's not that big. Okay, then you Docker build it. Fine, fine, fine. Okay, image name and then command Docker compose. Yeah, so there's another book I recently bought on Kubernetes. I think it was Kubernetes in Action by Manning, which I thought was really good. Which did a better job, I think, of explaining this stuff. So this feels a bit rushed, I think. Like, um, it is still nice to have it, but I would have appreciated maybe like something that's a bit more focused. Like, because the book is really What's mini KF? Mini Kubeflow? We're initializing VirtualBox. The storage volume for data used in experiments on Kubeflow created by Aritko. You see what I'm saying? Like the book has a pretty big scope. It's like, okay, well, here's how you can set up Kubeflow, and you have all these services. It's a lot of services, right? Cloud Resource Manager, File Store API, AI Prediction, Deployment Manager, Identity Access, Kubernetes, and Compute. Okay, so this is EC2. This is EKS. This is IAM. I don't know what the equivalent of this would be in AWS. I don't know what this means either. I guess this is like S3, like maybe something optimized for files. And then I don't know what this is. Okay, so now it's like, yeah, so you see, it's like, here's how you do the same thing, like on Azure, on Google. Installing Kubeflow using Terraform. Okay, so now it's also, let's use Terraform. You see what I mean? Like, definitely this deployment stuff it feels like layers of complexity. It's like you have so many choices and so many people trying to own the layer that you work at. So for example, like, like, oh, like you don't want to use a cloud provider, you'll use Kubeflow, which is like a layer on top. Or like, oh no, but you don't want to use Kubeflow. You really want to be using is Terraform or whatever. So I'm not really sure. Like, yeah, like it feels a bit unnecessary. Like, it's nice, I guess, but maybe have it in the appendix or something. Because it's like 100 pages of this, like Khatib. Represent. Okay, so building blocks of deep neural networks. So here's all the building blocks. Wait, really? I think maybe like you guys know how much I love this image, right? Um, I'll definitely check it out as soon as the stream is over. Then you don't need all of this detail. Like, I mean, it's okay. I get it, but it's not going to be someone's first deep learning book where they need to learn all of this from scratch. And even then, I think like it's generous, like it's nice, but like at the early CNNs and okay, and AlexNet, that's great. Okay, sure, dropout. Okay, so using Adam and second order methods. How does Xavier work actually? I mean, yeah, I think also because like by virtue, it's like what it's like as I'm zooming into. Oh yeah, I'm zooming in too much. It looks like. I think this is one thing like Pact could do better is like actually have proper LaTeX support in their books. So you see, like so far, like the best part was the code, right? Because this is interesting, but it feels like too much information. I think for me, like I don't need to know how every single architecture works, and but this is my issue with a lot of books, actually, not just this one. I feel a lot of books try to be comprehensive, like as if this is going to be the only book you buy, but that's just not true. I think for the most part, so this variation autoencoder is that yeah. So I think they could have skipped chapter 2 and 3. It feels like. So here they talk about KL divergence and a parametrization trick. I don't think this is the author's fault though. It looks like they didn't really have good like access to LaTeX. Oh, because yeah, this is LaTeX. Yeah, you see, you can zoom in. Maybe because like there's multiple authors, and that's what ended up happening. Okay, oh, this is the vanilla GAN architecture. So dense, leaky ReLU, dense, leaky ReLU. Then you reshape, then you have the. Okay, you create the fake examples, and you feed the real ones, and then have the discriminator distinguish between them. That's a neat trick actually to do this more. I guess deep convolutional GAN then yeah will be a similar idea. So just have more conv layers in between. Yeah, see here it's like a batch norm, but it was instance norm. Remember in the other examples we saw, and then it's this upsample. So this only upsamples, or is there a downsample here as well? So Z dimension. Oh no, so it's only upsampling. Is there a reshape at the end? Oh no, it's an activation. So what's the size of the output? Okay, never mind. Conditional GAN. Oh yeah, so this is what I was talking about earlier. That like some GANs can let you control the input. Sorry, control the output. So how does this work? Condition on specific characteristics of the output required. So they use class labels as additional conditioning to both generator and discriminator. And so you want an example drawn. Okay, yeah, sure. Where log, yeah, so this is the one I think for the real sample conditioned on y. So this is basically a loss for the distribution and then a loss for the class from that distribution. So conditional generator and conditional discriminator, I see. Yeah, let's look at the code's so much simpler, right? Looks very fancy here. Anyway, yeah, so like let's say it takes some noise, it takes a label, it takes a label embedding, doesn't take, it generates it. So basically this is the label that we want. And then the model input is we multiply some noise by the label embedding. Okay, sure. How does multiply a function? Okay, then same trick. Dense ReLU batch norm, dense ReLU batch norm. And then it reshapes it to the output shape MLP, which I'm assuming, yeah, so this is 28 by 28. So it reshapes it to be 28 by 28. And then the model takes in the noise and a label. Yeah, so it's pretty much what you'd expect, right? It just takes both as inputs. And then I think the secret is all in the loss function, which doesn't show up here. Yeah, so it should show up here where they train it. And when they train it, I think so. Which chapter is this? Chapter 6 is, yeah. Chapter 6 I think is really good. I think it's an excellent chapter. Um, which basically here. So let's go over the example. So we're gonna load in some training data, and then we're gonna create some fake data. And then we're gonna train the generator to predict uh, on noise and labels. We train the discriminator on a batch of real images, on a batch of fake images. We average out the losses, and then we're gonna train and then we're gonna train the generate use the train discriminator to improve generator. Yeah, so train the generator on the output of the discriminator, and then output both. So what's Wasserstein again? It's just a distance function, right? Yo, I see. I think I see Burke here. It's nice to see you. So, yo, how's it going? Thank you for the subscribe and gifting. It's very generous of you. I appreciate it. All right, so yeah, so I was basically saying, so I'm reviewing this book, um, Generative AI with Python TensorFlow 2. Like some friends at Pact gave it to me for free. I was going through the book. I think it's a bit verbose. It tries to cover too many stuff, but I think chapter 6 is amazing, and I think we'll explain GANs in a very, very clear way that you'll never forget. So I think this chapter is really, really good. Um, all right, last year, last year, last year, blah 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 blah, and then yeah. I guess Mr. D. Burke would say the same, actually. It's like, you go here and it's like, okay, it's very complicated. But then you actually look at the thing, you're like, okay, well, I'm going to take the mean of of their product. A lot of stuff is like this in this field. Um, all right, so what's a progressive GAN? So many GANs, like, it's like guess if can, pro GAN, PG GAN. I read that as PC GAN. Um, It's Matmul all the way down. Yeah, Matmul is all you need. By the way, I had an interesting conversation with this. Like, my girlfriend was telling me, it's like, oh, like, isn't it obvious that like it's all Matmul? I was like, well, this wasn't really obvious to me. I think I sort of figured out how it's all Matmuls about 6 years into it because these fucking images on like like neurons activation I just found were so damn confusing. Like people show me this, why do why do I care? Like it has nothing to do with this. Like this is cool, I guess, but you can't really compare it. There's no backprop, by the way, in neurons. Because the activation is like one way, and so like backprop is not really biologically plausible, and so why are we even going there? Just because it shares the word neuron? I think I had an ML teacher who once told me that like oh kernel trick is like I think he started talking about like they started talking about the kernel like kernels in OS. I think so, right? Like it's good for PR actually. I think that's a good point. It's like oh, it's like the brain. The example I like to think of was like Descartes. Like he had a theory for the what was it? The basal ganglia. Descartes theory of. Wait, let's look at Descartes. I think that there's an example I was thinking of here. Or was it brain? Oh yeah, the pineal gland. Okay, so we have this thing called the pineal gland. I think the people know what it does. It's a small endocrine system. Okay, it produces melatonin, serotonin. I think for a long time people didn't really know what it did. But Descartes' theory was that the pineal gland would control your brain via a series of pneumatic tubes. And one of the reasons he would say something like this was because like that's what sort of when thermodynamic like sorry when like water dynamics was getting more developed and like plumbing was getting more developed. So people were just using the analogies that worked for them, and not necessarily what was actually happening. It's just like it was a good lens by which to view this problem. Um, oh, interesting. So this is like I think how the NVIDIA super resolution stuff works, right? So you just keep bumping up the resolution. Oh, and they do it step by step, so slowly increase resolution. I guess like this makes it a bit more easier to train. Okay, I wish this book was just chapter six. I think. Like, I think I would have read the fuck out of it and recommended it over and over again to people. Okay, now they do style transfer. Let's see if it gets better. Let's see. Style transfer, paired pixed again. Told you, unit shows up over and over again. Like I think it's really strange, right? Like how just this, like the idea of skip connections from ResNet is sticky. Like that idea is probably not like it's Lindy, right? Like it's probably not going to go away anytime soon. And I think like the idea of UNet is just yeah, this encoder decoder architecture as well. Probably this idea is Lindy. Like these are probably going to stick around. I think Mr. D Burke is probably going to do like a 15-hour video on ML ops. Like I think I won't be satisfied with anything less than that. So SOTA for univariate is this pure MLPs plus skip connections. It makes sense because I think the like I think people expected that if you need to give a sequence that you need to give the input step by step. They didn't consider that you could just give like you could basically set the window size and feed it in batches and then have the positional encoding. So that's I think one idea from Bert that will probably stick around. And then once you have that, I think in the RNN and like the NLP communities, typically, people complained a lot about the vanishing gradient and exploding gradient problem. And that's right. I also think like these skip connections are probably going to be very sticky. I think everything else seems like maybe it was like that wasn't like I think what maybe the core idea in CNNs wasn't even like it's not even the translation invariance that was important. It was the being able to aggregate information from several channels that was important. So whether it's from several channels or from several layers, just basically making sure that your signals mix up. So what is the like I guess at a high level, yeah, and like normalization is just changes, right? It's like just okay, is it batch norm, is it instance norm? I think I had a tweet that compares all the different norms in like a single line of code, and I think in Einstein summation they're a bit easier to explain. I think, like for example, in norm, if you look at batch norm, like if you look at the math for it, it's not entirely clear what are you normalizing over. Is it like I mean, I guess in this name, right? It's obviously it's the batch, but I think like so a lot of this notation could be made simpler. I'm not going to scroll back see where they define batch norm here. But yeah, I think a lot of this could be made a lot simpler. Um, okay, so training. What's pix to pix again? So he looks the exact same. Like they all have the same. That's why I said chapter six is so good. Next is a large scale project of my own, skin in the game. Um, like I would definitely highly encourage that because I think there's like only so much you can do. You only so much you can do teaching stuff because like at the end of the day, like you want to either do something useful or make lots of money doing it. That's why I really like Jason Antic. I don't know if he's watching this, but so Jason, I met in San Diego, and he created. I don't know, follow him. Yeah, so he's in San Diego, and he created Deoldify, which is a project to restore old images, and it works like crazy well, actually. Like and I think it's interesting because it gives like it has like I mean these are really good examples. It's beautiful. Like it gives you like I mean I was able to do this and I was able to just take some of like my old like grandparents photos and see what they would look like because I don't really know what my grandparents looked like when they were young. So I think this is very powerful and it's just like a very simple example of how you could potentially uh, the model had to work on an iPhone 6s. Yeah, unfortunately he's not on Twitter anymore. I think he got burnt out from it, but it's a shame. Like I think he's a really interesting guy. I also met Dana too. These are really cool images they picked. Who's this Chad? I can see the bathing suit. Okay, so let's go back. Where were we? Sorry, I got lost. So, like, maybe I'll should I do the full streamer mode and actually give a score for this book as well? Let's see. So if I were to like, I mean, I'm almost doing this ironically, but if I were to, let's see, let me see if I can do something somewhat objective. Like, so I think when I think of a like a book, you need to download Better TV to be part of the Twitch gang. Yo, you should just make Pseudomaze your mod. He'll like improve everything for you. This is, this is what I did. It's one of the best decisions ever. So yeah, when I think of a technical book, I think basically, is it clear? Does it have code? And this is a bit harder to qualify, but like, is it sort of inspiring or sort of synthesizing? I guess is what I want to say. Um, yeah. So yeah, I don't know. Fuck this. I don't want to do this. I think split the book into two parts. I think I don't know. I think these 9/10, 1/10 scores aren't very useful. It's like I think there's maybe like it's a binary classification, right? Like, do I recommend this book? Yes or no? I think I would recommend chapter six. Like, I think chapter six is all you need. Let's look a bit more. Look at the rest. Let's see. It's disco again. Yes. So one thing, I mean, like I think Jason uses all sorts of tricks to make his product work, but I think like the interesting thing about this is that well, you could take colored images and make them black and white and try to recover the photos. Are you sure you want me to read like your Discord chat here live? And I told you the world's gonna know like about like your disturbing thoughts. All right, so deep fakes with GANs, deep fakes overview. Basically, do any games use GANs? Like I've heard, okay, sure, like in the context of Doom and stuff. Are these interesting levels? Oh, with secrets and stuff. That's kind of cool. All right, I'm gonna open up the message, but like I'm not gonna, be responsible for any reputational consequences from this. Let's see. The pseudomaze. Oof. Well, they're being nice and giving me free books. Let's not be too harsh here. I think what you're saying is like it's a point around the comprehensiveness. Like, oh, it's a book that needs to be the Bible on GANs. And I just think like that's sort of not a worthwhile goal, to be honest. Like what I would rather have a book do is say, like, look, here's the general architecture of these things, and then if you want to tweak it, here's how you would go about doing it, or the things you would need to go about doing it. So it's sort of like, what is the software pattern that lets you do generative modeling in a very efficient way, such that if you read a new paper or read a new code base, that you can sort of quickly compress it and re-implement it yourself. I think not enough books do that. So like I think that's maybe if I were to do things a bit differently. Because like for example here, like they have this whole notebook example around like how to do landmark detection. And then once you find the landmarks, I guess they use them as a signal. Okay, so here what do they do? So they get intermediate representations or features, but like ideally, like you could say, oh, interesting. Okay, that's good. That's good. Uh, Generated face into target as cleanly as possible. Okay, so again, encoder, decoder, GAN. I mean, like see, this is a bit weird, right? Why are you talking about GANs 300 pages into a book about GANs? Like you explained this already. It's okay. I think the only thing I can explain here is maybe the it's just written by different people, like they wrote different chapters. So okay, aligned face. What does this do exactly? No, come on, you can't explain autoencoder again. Like this book could have been a third of the size, I think. Um, Input and output examples. That's an interesting point. I think the book that made me sort of get the whole input output aspect, yeah, like I think the book that made me get it was Deep Learning in the Game of Go, because what they do there is that like they sort of take this one example, but then they just like they're like, okay, we're gonna use the simplest trick, like just like a neural network. And then it's like, okay, well, we're gonna add crazier stuff, or we're gonna just predict from real games, and then we're gonna do self-play. And so they slowly build up this thing. And one of the things I really liked in that book was they showed me the first example I'd seen of models with multiple inputs and multiple outputs in Keras. And while it seems like sort of a trivial addition, like I mean the book is it's not that big, it's just like maybe like 300, 400 pages at the most. But what I really liked about it was I was like, oh, I see. So it doesn't need to be just a matrix. Like I can give data structures as inputs and outputs. And that's how I think ended up writing that article around, can I use deep learning for that? Because it sort of helped make that framework very clear in my head. So that's why I think that book is exceptional. Probably the best intro ML book I know of. But I guess like so many people, like not many people are gonna read it because it's like, oh, it's about Go, right? Or it's like, oh, who cares about game AI? Like I want to predict rent prices in San Francisco. Like that seems to be a lot of tutorials. Or MNIST. Yeah, this feels a bit too specific. Don't you agree, boys? Like I feel like talking about uh, doing landmark highlighting in on images is probably not okay. How you define a vocabulary. It's a shame because I feel bad because I know that this is an insane amount of work. But at the same, I don't know if it's that valuable. It feels kind of grindy. Like you really need to explain glove, like you need to explain like the five different ways of doing embeddings. Uh, it's a shame. Like it's a lot of work, Like or maybe it's not. Maybe it's just like you sit down every day and you like look at an example and you do an image, so then it makes it easy for you to scope your work. I don't know. I think yeah, it seems like Manning and O'Reilly have the highest standards among technical books. But to be fair, it's been a while since I found an exceptional book by either of them. I think at least the deep learning ones, it feels like most of the good books have been written to me, and now it's like, yeah, sure you can do a book that's sort of incrementally better, but um, I mean that's why I mean I've had people ask me like, why don't you write an interesting deep learning book? I just kind of don't feel like it because I feel like there's already really good books that exist on the topic. I'd rather write about something else. One book I've been procrastinating on, like after I wrote the Robot Overlord manual, I thought I would get started quickly on a book on multi-agent game theory and dynamics, so RL in the multi-agent setting. Because I think there's still no book on this topic today, but I never got around to it. Like I think I started working at GraphCore, that was just intense. At PyTorch, it's even more intense. So we'll see. I think actually. Let's see what Mr. D. Burke, what do you think is a more realizable goal? Like I think I was thinking about like what would be cool to do this year, and so I've been going kickboxing every week, but I just like get it's like I feel like even fitness wise, like I'm not there yet. Even just like even me kicking or putting my hands up like for an hour with the workouts and the squats and whatever, like I can barely breathe by the end of it, let alone like also being punched in the face with it. So I think it would be cool to get into an amateur fight by the time the year is done, or maybe write that game theory book. I think would also be cool. I think maybe uh, like maybe the game theory book could be interesting from a perspective. Try to play soccer. Yeah, I mean I played soccer a bunch as a kid. Then I just like started playing FIFA and I stopped playing soccer. Um, yeah, I see. This is a bit fluff, right? Like, okay, like how to do Hugging Face. Like, it's not why I'm buying this book, right? It's not an NLP book. It's a whole chapter just on generating text. I think. Like you see, they don't even talk about generative NLP. There is no example here where you're putting it on hard mode, striking plus fitness. Yeah, dude, it's brutal. Like there's these exercises where even they give us like these like 2 kilo weights. Uh, but then you do like repetitive movements with them. So you do stuff like this or like this. It's like I can barely feel my arms by the end of it. It's like way harder than like doing like larger weights. But holy shit, dude! Like I feel fighters like they're just like in such insane shape. Like there's so many chads in that gym. It's like kick like trucks. Okay, so here I guess they're using LSTM to generate stuff, which is cool. Um, so this is one of the better chapters. You see again, like they're replicating the same code. Like here, you don't need to really repeat this. Like this code, we've seen this code 10 times. The author of Soccermatics hosts this show, just bug you. Oh, I'll check it out. I'm barbell set for health, long walks, high intensity lifting weights. Yeah, I think like I've been really enjoying long walks too. I found this, and it's like I guess better food. Like I found this Greek place here close by, where by the way, like now when I go out, I realize even if I'm getting like a burrito, if I'm paying for 2 people, then I'll pay like $40 for something that's essentially fries and bread or like just I don't know water or oil or whatever. I found this like Greek place called Alexis, and it's like for $8 gives me like this like mountain of shawarma, and it's like absolutely amazing. And the guy who works there is like this like crusty guy who has like no tact or anything. It just gives you good food at like a price from the 80s. The best guy ever. I've been going there every day for the past like 5 days. Fucking amazing. Um, okay, yeah. I feel like this is a bit of a better chapter. So, okay, so here with RL, MDPs, it's like Pi Bullet Gem, Actor Critic. See, like it's a bit, it's all over the place. Like, okay, like the GAEs, and the syntax highlighting isn't like consistent. Like it's a different format. Okay, so emerging applications, sure, like molecules. I've thought like this is I actually talked literally about this. So the smiles encoding is a way of turning a graph into a string, so then you can use RNNs for it. But you have GNNs that work just naturally over graphs, so you don't really need that. It's just useful if you don't want to use any new kind of model. You can solve. Okay, so I think we can sort of review this right now. So let's just do the review right now, and then we can call it probably. Where is it? Review. Okay. So really, I think let's see if we can write the summary. Oh, by the way, I bought this like £8. America's weird sometimes. Eight pound popcorn because a 30 ounce is $5. So anyway, it's not important. Um, so let's see here. So I think like what I liked about the book is that um, the main things I okay. So the main things I really loved about this book are the code and chapter 6. Chapter 6 gives an excellent framework for how to compare the various flavors of generative models and GANs and abstracts them away in a common. So it abstracts them away in a common architecture. So I now feel like it would be pretty easy to learn about a new GAN architecture. So wait, where was the code? Generative AI packed GitHub. Yeah, sure. The the code on GitHub makes this uh, even easier because you can just pull in the examples, the repo in a Google Colab notebook and see for yourself how everything works. Um, the main weakness this book has uh, is it ends up repeating lots of content. Like for example, the basic code for discriminators and generators. Uh, or explaining way too many things and that I think is not too bad. I think it's fine that the topics are disconnected because I like I want to learn about images, I want to learn about video, I want to learn about audio. What I didn't like was sort of like, okay, well, here's Terraform and here's Docker, a lot of, like, for example, the basic code or explaining way too many things uh, that aren't really essential to understanding uh, generative models, like a comprehensive overview of neural networks or cloud deployments, which detract a bit, which would detract away from how clear chapters like chapter 6 are. Uh, as far as the examples go, the NLP section is 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 weak relative. The NLP section is weak relative to the audio and image sections. With the image sections, uh, with the image sections playing a with the image sections definitely being the star of the show. So all the related content, like all the content that's not generative modeling, uh, may still be valuable if this is the first deep learning book you've bought. But if it's not, and you're really buying this to learn more about GANs and GANs and friends, then you can read chapter 1, 6. So wait, let's go over the chapters again. So chapter 1. No, wait, 6, or was it 6 or 4? I think it was I kept saying chapter 6, but then it turns out maybe it's 4. Oh, it's 5. Let's see. Chapter 5. No, no, I'm pretty sure it was 6. Yeah, yeah, it was 6. 6 is the winner. So yeah, so 1, 6. And then, yeah, and then 9. Then 9 and skim the rest. And skim the rest. You can architecture. Um, you can architecture. Reading a lot like the basic code. Explain a way to make the aren't really essential general neural or cloud deployments with Terraform or Terraform and on Google, AWS, and Azure, etc. From how clear as chapters like this. So. All right. All right, I think that's probably it then. I hope y'all enjoyed this. Let's see, what can we do next?